Okay, with this tutorial, I'm going to show you how to build the 45-degree elbow in SolidWorks using the Revolve command. So the first thing I'm going to do is create a brand new sketch on the top plane. I've already selected my material as plain carbon steel. My units are inches, pounds, and seconds, and I'm in ANSI drafting standard. So I'm going to click on the top plane and I'm going to draw a circle. And this circle represents the outside diameter of the elbow, the main midsection of this part. So to get that, it's going to be the through hole, which is 1.62, plus 0.375, plus 0.375, 3/8 per wall of this circular tube. So when you add all that up, it comes out to 2.37, but this is all, these numbers are all fractional. So it's safe to assume that the outside diameter would be 2 3/8. And I can round that up to 2.375, and then SolidWorks will round down for me. So it's very minor. So if there's a fraction on a blueprint, this is my approach. And now, because I'm using the Revolve command, I need to sketch a center line which represents my axis of revolution. So I have a infinite length center line at some distance to the left of my origin, but if I think of this as my center line, it's also going to be the radius that you see on the blueprint in the front view. So the 4.88 radius is the key. So now if I put my isometric view on, all I have is a circle that's attached to my origin and a center line, an infinite length center line that's 4.88 inches away. Now if I select Revolve, SolidWorks wants to take this circle and revolve it 360 degrees around the axis of revolution, but that's not what we want. So we don't want 360, so I'll switch that to 45. So now looking at it from the front view, we have drawn that circle on the top plane, and now that circle travels up here to 45 degrees. We know our center axis is correct because it's part of our sketch, so that in fact is our radius. The nice thing about this is now I can edit this feature, change it to 90 degrees, change it to 180, 270. I don't think it would go to 360, but you can see we have a lot of functionality where if I had a flange here, this would be my driving feature and would move that flange to those locations. So I'm going to set this back to 45. Put my isometric view on because I know it works. I know it doesn't fail. I can manipulate it, so that's good. My sketch is pretty concrete because all it contains is a circle and a line, a center line, so it's pretty simple. And we've got a ton of functionality with this feature now. So perfect time to click File, Save, because I don't want to have to do any of that again. Now I can choose to model the base or the top flange. So I'm going to start with the base. So I'm going to sketch on the bottom surface of the part. Or I could sketch on the top plane, either or. And I guess I'm going to sketch on the top plane. It's a little bit more robust. So sketching on the top plane, which is also on the bottom of the part, I'm going to create a center point rectangle. I'm going to set the left or the right and top as equal because I want a 3.75 square. So from here to here is 3.75. And if you want to be fancy, before you exit the sketch, on the left-hand side, you can just hit this little square symbol. And now it tells the machinist that this is a 3.75 square. I'm not going to add the fillets or the drilled holes at this time because I just prefer to make them as features. So now it's extruded, and I'm going to move on to the top flange next. Um, Actually, I'll do a quick file save. And now I'll sketch on the top surface. I'm going to draw a circle off to the side and dimension it to 3.88 per the blueprint. And now I'm going to manually add a relation between this circle and this circle, forcing them to be concentric. I like to draw the circle off to the side and manually add the relation. I just think you get it right 100% of the time if you do it that way versus letting SolidWorks assume or guess. So now I'm going to add a extrude in this direction, not that direction, because that would make the part too long. I think the angle would change. We want it here. The end of our angle stops at the end of this elbow, so I don't want anything going past that. Okay, so you'd have to hit the reverse direction button in order for that to work. Okay, and now I can go ahead and add the large 9/16 fillets at the bottom. I can do all four at the same time. And then I can go ahead and add the 1/8 fillets everywhere else. So here, 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 and here. I can now add the drilled holes at the bottom, and I'm going to use Hole Wizard. Pre-select the surface I want to put the hole on. And from Hole Wizard, I want a traditional hole, ANSI inch. I want fractional drill sizes. You want 3/8 as your size, and you're going to hit through all. Once you define the type of hole that you want, you're going to click Positions. And in this case, we don't need any dimensions or relations, right? All I have to do now is bring my cursor over to this silhouette edge, and you'll notice the center appears. So I can just kind of drop the point right on top of that center. And I can do that for all four of these 3/8 holes. And then when I'm done, I can exit out of the point command, and you don't want to see any blue geometry. You don't want to see any blue points. All right, if you see a blue point, it means you missed your relation, and you'll have to add it manually. So I'll put my isometric view on. I'll hit the green check mark and exit out of Hole Wizard. And before I do anything else, I'm going to make sure I have no negative signs to the left or underneath Hole Wizard. So I'm good. I have no negative signs. I'm going to hit File, Save. And now I'm going to focus on the center, the 1.62 center cut hole. So I'm going to cheat. I'm going to go over here to Sketch 1, and I'm going to show that sketch.